All right, so in this video, I'm simply going to work on factoring all of the trinomials on this worksheet. What I would recommend for you to do is to watch and do the first couple with me, and then pause the video and see if you can work the next one by yourself. And if you can, keep on doing as many as you can while checking the answers until you've got it. If you're having a hard time doing it by yourself, then I would turn the video back on so that I can guide you through it step by step. And in this way, you'll gradually get through the problems on this worksheet. And once you do that, you'll probably have a pretty good handle on factoring. I am going to let you know that some of the ones on the worksheet are beyond what you'll need to do in this course for this year. So I'm going to say go ahead, cross off number 9, or sorry, number 8. We're not going to look at number 8. That's not a good example for our intents and purposes. And then on the back side of this worksheet, number 9 isn't suitable either, nor are numbers 16 or 18. So just know ahead of time, and I want you to cross those off ahead of time because I'm not going to do them in the video, and it will therefore not be in your best interest to spend your time doing them either. So notice, first of all, that for each of these problems it says to factor. Factoring just means we're going to find, in this instance, the binomial pair that when we multiply it together yields that trinomial, as opposed to solve. And when we solve something, we would be finding an x equals or a p equals. But in this case, all we're doing is factoring. So that's an important thing to notice as well. I'm going to dig my calculator out. You're going to want your calculator as well for doing this. And then I'm just going to go ahead and jump right in. Just a reminder that there are a lot of different ways that it's possible to factor. The method that I'm going to use is one and only one of those. But I'm going to go ahead and start by multiplying the coefficient of the squared term, 3, by the constant, -5. And those guys will multiply to be -15. And I'm going to go out in search of factors of -15 whose sum is -2. And I know that if I multiply -5 times +3, that yields -15 for a product and -2 for a sum. So they are my winners. They are the ones that I'm going to use. I'm going to go ahead and set up this little table or this little grid. And in my table, first term goes in the first box. So the 3p squared would go in the first box, last term in the last box. And notice that when I bring that -5 to the last box, I bring its sign, that negative or that minus, right along with it. And then the other two boxes are going to be a -5p and a +3p. And I got those numbers because they were the ones whose product was the -15 and whose sum was the -2. And notice now that if I go and combine all 4 terms in my box, or in my grid, or in my table, those 4 terms will all combine to give me the 3p squared minus the 2p, subtract the 5. My next step is going to be to go ahead and to look across the first row in the box. And when I look across the first row in the box, what I'm looking for here is a greatest common factor. The greatest common factor of those terms is p. So I'm going to go ahead and write that outside the box. And now it's all a matter of p times what number gives me 3p squared. Well, p times 3p yields 3p squared. P times what number gives me -5p? -5. 3p times what number gives me 3p? Well, that would be a +1. And then lastly, a check of -5 times +1 is -5. So that tells me that indeed I did my factoring correctly. So one of my binomials is going to be what you see across the top of the table, the 3p minus 5, and I'll write that in the first parentheses. And then the other binomial is going to be what you see down the left side of the table, in this case p plus 1. And at this point, we're done. I'm going to go ahead and move on to number 2. Number 2, again, I'm going to go ahead and I'm going to start by setting up that grid or that table. First term in the first box, last term in the last box. And now I'm going to go ahead and multiply the coefficient of the squared term times the constant. And that's negative 18. And then I need to find factors of negative 18 whose sum is positive 3. So I like positive 6 and negative 3. So in one of these boxes goes positive 6n, and the other a minus 3n. I'm going to go ahead and look across the first row in the table. Greatest common factor between those two terms looks as though it's going to be a 2n. 2n times n gives me 2n squared. 2n times positive 3 gives me 6n. N times minus 3 is a minus 3n, and a minus 3 times a positive 3 is a minus 9, telling me that I indeed did the factoring correctly. So as far as my two binomials are concerned, one of my binomials is n plus 3, and the other 2n minus 3. Remember that it doesn't matter which order you express those in, because multiplication is commutative and you can change the order without changing the answer. All right, at this point, if you're feeling rather secure and confident, you can go ahead and pause the video and try number 3 on your own. If you get stuck, just resume the video and you'll have that support that you need right there. But if you don't, just go along and check your answers, and as long as your answers are checking, you're doing factoring beautifully. All right, I'm going to go ahead for this one, set up that table. First term in the first box, last term in the last box. 3 times positive 4 is positive 12. Factors of positive 12 that add to be minus 8n. A minus 6 times a minus 2 is a positive 12 when I multiply them, and a minus 8 when I add them. So I like minus 6n and minus 2n. Look across that first row for the greatest common factor. Greatest common factor of those terms is going to be a 3n. 3n times n gives me 3n squared. 3n times minus 2 is the minus 6n. N times minus 2 is the minus 2n. And then the minus 2 times the minus 2 do multiply to be the positive 4. So my binomial factors are 3n subtract 2 and n subtract 2. All right, cranking right along. Number 4. Let me go ahead and erase some of these spots that I've gotten on here. First term, first box, last term, last box. 5 times positive 12 is positive 60. And now I'm looking for factors of positive 60 whose sum is positive 19. And this is where, if you're really not sure of those factors, your graphing calculator is going to be super helpful. So I'm going to take a minute and go ahead and grab my graphing calculator. And I thought I could show you this on my computer, but apparently I can't. What I want you to do is on your calculator, start by turning the calculator on and going home. Once you're at the home screen, press 1 for New Document and No to save the unsaved document. And then you want to go in and you want to add a graph. And that's kind of counterintuitive, but you'll see why in just a few minutes. Once you've added a graph, we want to make f of x equal to a fraction. To enter a fraction in the calculator, you're going to hit Control and then the divided by key. The numerator of your fraction will always be the number that you're trying to find factors for. So in this case, I'm going to enter 60 for the numerator of the fraction. The denominator of the fraction will always be x. So I'm going to graph the function f of x is equal to 60 divided by x. And it's really not the graph that I'm so concerned with, because once I pull up the graph, I'm going to go ahead and find the table. And what's very cool about the table is the table will contain all of the factors of positive 60. So I'm simply going to go look through the table with all of the factors of 60 until I find the one whose sum is positive 19. So now I can see by looking at my table that the two factors of 60 whose sum is 19 are positive 4 and positive 15. So that's kind of my little trick to find factors if they're not easily apparent. All right, greatest common factor for the top row is going to be n. So that's a 5n. This is a plus 4, a plus 3, and then a quick check there. Positive 4 times positive 3 is positive 12. So 5n plus 4 times n plus 3. And again, at this point, if you're feeling confident, you don't need me anymore, feel free to just turn me off and go factor. Just make sure you check your answers and you're getting the right factors. I'm going to continue to factor in case anybody needs me. Plus, I'm just having fun. All right, first term, first box. Last term, last box. 2 times 5 is positive 10. Factors of positive 10 whose sum is positive 11 are positive 1 and positive 10. So greatest common factor, when I look across the first row, greatest common factor there is going to be v, making this 2v plus 1 plus 5, and a positive 1 times a positive 5 is a positive 5. So 2v plus 1 times v plus 5. Next one, first term, first box, last term, last box. 2 times 2 is positive 4. Factors of 4 whose sum is 5 are going to be a positive 4 and a positive 1. When I look across the top row, greatest common factor there is that 2n. 2n times n gives me 2n squared. 2n times positive 2 gives me a positive 4n. N times positive 1 is my positive 1n. And lastly, my check, positive 2 times positive 1, positive 2. So n plus 2 and 2n plus 1. Oh, number 7, this one looks good. This one looks like the calculator is going to be a super helpful tool for me here in finding those factors. So I've got a 7a squared in the first box, a positive 28 in the last box, and then I want to do 7 times 28. So I'm going to go ahead and dig my calculator out. So I'm looking for factors of positive 196 that add to be 53. And again, this is where I'm going to go right for my calculator. I'm going to open up a new document. And when I open up a new document, I want to add a graph. And in that graph, I want my f of x to be 196 divided by x. So that's what I'm going to enter into the calculator. And again, I really don't care about the graph. What I'm looking for is the table, because that table of values is going to contain all my factors of 196. So it looks like from that table, positive 4 and positive 49 are going to be the ones whose sum is positive 53. So plus 4a in one of the boxes, plus 49a in the other. And now I'm good to go get to work. Greatest common factor of 7a squared and 4a is going to be a. A times 7a is 7a squared. A times positive 4 is 4a. 7a times 7 is positive 49, and that would be a positive 7. And lastly, my check, positive 4 times positive 7 is positive 28. So I like for the factors here, 7a plus 4 times a plus 7. We said to skip 8, so that makes that one easy. 9, we're going to skip also. And I'm going to keep cranking and plugging along and go right to number 10. First term, first box, last term, last box. 5 times 9 is positive 45. And I'm looking for factors of positive 45 that add to be negative 18. So I like minus 15 and minus 3. So minus 15x for one of the boxes, minus 3x for the other. And I'm off to the races. Greatest common factor there is going to be that 5x. So let me go ahead and pull that out. 5x times x is 5x squared. 5x times minus 3 is minus 15x. X times minus 3 is minus 3x. And my check, minus 3 times minus 3, positive 9. So my two binomial factors are 5x subtract 3 and x subtract 3. Ooh, this is fun. All right. I'm guessing probably nobody needs me anymore, but if you do, I'm going to keep on factoring because I'm a factoring machine here. All right. So let me go ahead and get my table set up. I think my tables are getting smaller and smaller. 4 times minus 25 is minus 100. So I'm looking for factors of minus 100 that add to be minus 15. I know these right off the top of my head, but if you don't, just go to your calculator and graph f of x equals minus 100 over x. And in that table, you'll find all the factors of minus 100. But I'm liking minus 20 times positive 5. They multiply to be negative 100, add to be negative 15. So minus 20n plus 5n. And now that my table's filled in, time to go get to work. Greatest common factor between the terms in the top row is going to be a 4n. 4n times n is 4n squared. 4n times minus 5 is minus 20n. That's going to be a plus 5. And lastly, my check, negative 5 times positive 5 is negative 25. So my two factors here are n subtract 5 and 4n plus 5. All right, number 12. Again, I'm going to go ahead and start by making my table. This time I'm going to be a little bit deliberate and make it a little larger. So 4x squared in the first box, positive 49 in the last. This one too looks like a great candidate for the calculator. So 4 times 49 is positive 196. And I'm looking for factors of positive 196 that multiply or add up to be negative 35. And again, I need my calculator for this, so I'm going to go enter into my calculator f of x equals 196 divided by x. And once I do, I'm going to go right for the table. And in that table, I'm going to be looking for the ones that multiply to be negative, or sorry, add to be negative 35. So I'm liking negative 7 and negative 28. They multiply to be positive 196, but add to be negative 35. So minus 7x minus 28x, and off I go. Greatest common factor from the first row is going to be an x, which makes this a 4x, and this a minus 7. This is a minus 7, and a quick check, minus 7 times minus 7, positive 49, making my answer 4x minus 7 times x subtract 7. Beautiful. All right, number 13. First term, first box, last term, last box. So I'm looking for factors of positive 16 that add to be negative 17. So I like negative 16 and negative 1. Greatest common factor from the first row is 4n, making this n subtract 4. This is going to be a minus 1. And again, that little check tells me that indeed I'm on the right track. So my factors here are 4n minus 1 times n minus 1. Moving right along. This one too looks like a good candidate for the calculator. First term, first box, last term, last box. I'm going to go ahead and do the 6 times the negative 49. So I'm looking for factors this time of negative 294 that add up to be positive 7. So again, I'm going right for the calculator, and I'm going to graph the function f of x equals negative 294 divided by x. What I'm really concerned with is the table. So in that table, I'm going to be looking for the factors that add up to be 7. So it looks like positive 21 and negative 14. I never would have found those without the calculator. So one of these is a positive 21x, the other a minus 14x. Once I get those into my table, greatest common factor across that first row looks like a 3x, making this fella a 2x and a plus 7. 2x times minus 7, and then my check at the end. So my two factors are the 2x plus 7 and the 3x minus 7. All right, moving right along. I'm on to number 15 now. So again, first term goes in the first box, last term goes in the last box. I'd be surprised if anybody's still with me at this point. So I'm looking for factors of 36 that add up to be 37. So I like positive 36 and positive 1. Greatest common factor across the top looks like it's going to be 6x, making this an x plus a 6. A positive 1 over here. My two binomial factors, x plus 6 and 6x plus 1. And the last one, number 17. Dun, 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 dun. First term, first box, last term, last box. 6 times minus 6 is minus 36. Factors of minus 36 that add up to be 5. I like positive 9 times minus 4. I found those pretty quickly, but if you needed to rely on the calculator, use the calculator to find those. Greatest common factor from the top row is going to be 3n, making this a 2n plus a 3 and a minus 2 over there. And lastly, for my check, a positive 3 times a minus 2 is a minus 6. So for the binomial factors here, I like 3n minus 2 times 2n plus 3. All right, and if you've hung on this long, my thanks. Hopefully you've gotten to be a better factorer by this point. But if not, please feel free to ask me for some additional problems and we'll get you squared away. I feel pretty confident of that.